Well, you're right. This is a Wolfram Alpha problem. Anything that says the graphing utility usually be done on Wolfram Alpha. First of all, the y-intercept we don't need Wolfram Alpha for. We see the only constant term is what's left when everything else is set to 0, and that's what happens when we get to the y-axis is all these values, multiples of x, are set to 0. So we have negative 0.25983, and that's the y-intercept. Good job, it says. Now we get to the x-intercepts. And so we have to get here, and typing x-intercepts, Wolfram Alpha, for some reason, gags on that. The word it seems to like best is the word roots, which is another synonym for x-intercepts. Let's take a look. See if it does the right thing this time. Okay, so now it's going to slice, dice, and julienne. And so it has these three x-intercepts, negative 1.11824, negative 0.1919982, and positive 1.2102. And so we go back here, and the x-intercepts are, we round to 2 decimal places. So first option, negative 1.118 rounds to negative 1.12. Negative 0.1919 rounds to negative 0.19. And finally, 1.2102 rounds to positive 1.21. Nice work, it says. Okay. And so now we get here, and now we got to use table, and the proxy for table is Excel. And so what we do is we go into, well, Excel, like, it's probably the easiest thing, and you have it. I remember you have it now. It'll behave pretty much the same in each. What you do is you put each of these x's down for x, so that each of the x values possible. So they want, like all of these, they want the x values negative 2, negative 1, no. Okay, so no comma on negative 2. Negative 1, 0, 1, and 2. That's what we want for the x's. And for the y's, we want to know, well, let's see, let's take this x and cube it, plus 0.1 times this x. Oh, crap. Try again, times this x, and square it, minus 1.3711 times this x, and minus 0.25983. Okay, so that makes this cell f of negative 2, and we'll just copy and paste down. And so now each of these cells is f of negative 2, f of 1, f of 0, 1, and 2. Okay? And so we've got these items here. And so which one of these is correct? Let's see. The first one has negative 2 paired with positive 5.12, so that doesn't work. The second one might work. Let's check negative 1 paired with positive 0.21. 0 is paired with negative 0.26. 1 is paired with, ooh, that's a positive. That's not going to work. Let's check this next one. Nope, that has negative 2 paired with positive 0.512. Ah, here, D. Negative 2 is paired with positive 5.12. Negative 1 is paired with 0.2. 0 is paired with negative 0.26. 1 is paired with negative 0.53, and 2 is paired with positive 5.4. So this is the one that's correct here. Let's check the answer. Well done. And now we're going to try to determine which intervals the graph is above or below the x-axis. and I kind of hate this. Let's see if we can get this onto a notepad here a little bit better, okay? So, what's been determined? Let's draw a number line here. Quick number line, okay? Oopsie, no. Try again. Quick number line. Here we go, okay? So I've got a number line. And furthermore, what we've discovered earlier were that there were x-intercepts at negative 1.12, negative 0.19, and positive 1.21. So let's just kind of mark these intercepts. Negative 1.12, negative 0.19, and positive 1.21. I'm still marking it up here. I have a pen here. I'm not sure why I'm marking these up with these pencils. Anyway, here we go. And negative 1.12. There we go. Okay. Now, what we have is these other points where we figured out what's going on. I'm going to mark them in red. And one of them was negative 2. Now, when x is negative 2, we discovered that y was also negative, namely negative 5. What that tells us is that before negative 1.12, the function is negative, because it's only going to change. A polynomial is going to be continuous. Its graph's going to go up and down without leaping off the paper. The only way it's going to change from negative to positive is if it crosses through 0. And this is one of the places where it crosses through 0 is right here. So it's not going to change here. Now, another thing a polynomial can do is bounce. So we do have to check what's going on this side. Well, that's been told to us by checking out negative 1. When we checked out negative 1 as a point, negative 1 had, let's see, positive 0.21 associated with it. So what that tells us is that between negative 1.12 and positive 0.19, or negative 0.19, the function is positive. Okay? And then between 0.19 and 1.2, we also have a couple choices here. Let's look at 0. At 0, it is negative something, I bet, right? Yeah, at 0, we were mapped with f of x being negative 0.26. So what that tells us is that everywhere between the two zeros, here and here, everywhere between these 2 points, we've got to be, oopsie, let me check it out, 0, 0, 0. Let me make sure I've got the right thing. Negative. It was negative 0.26, so that's right, it would change to negative. And again, it can't turn back to positive without crossing through a 0. So then we check after 1.21. The only option we have is positive 2. Positive 2 was associated with a positive number, 5 point something, and so we knew it did turn back to positive here. So what we've got to look for is something that says it's below 0 on this first interval and this interval. Okay, so let's check it out. Below 0 on here and to 1.12, and below 0 from negative 1.9 to positive 1.2. That looks good right there. So that happens to be described by A. If it weren't described by A, what's going on in this picture? You'd keep going down until you find something it did describe. Fantastic. Excellent. Okay. Locating any turning points. Okay, at this point, what you have to do probably best, I don't know if there's a trick here, but you look at Wolfram Alpha and make a guess. You might not be able to get, oh, I know what you do. The turning points here are called, this one here is called a local maximum. So that local max, so you just type local max, hit enter, and it's going to hopefully tell you where the local max occurs, approximately 0.71 negative. And so we go back in, approximately 0.71 negative. Let's see if it likes that. Oh, it doesn't like it. It must be in the form of an ordered pair. Oh, those bastards. Okay, and so let's check it out. Go back here. Let's see if they gave us the local max. Yes, they did. The local max is 0.41. And so, oopsie, here we go. 0.41, so we go comma. .41. Yeah, it's liking that better. And the local minimum, well, we can find that again by just typing local min. After the function, of course. And so it looks like we've got at x equals 0.64. The minimum value is 0.83. 0.64 negative 0.83. Okay, and so let's see how it takes that. Okay, so it's okay with that. And so using the information that we got, let's see what we have here as a graph. So first of all, let's look at what looks even roughly like our graph in here. And there's going to be two options that look like our graph from alpha and two that don't. Looks like these are the only two that look roughly like our graph in alpha. And then we start examining the details. Negative 0.71, 0.64. Ooh, it looked like when we were at negative 0.71, our maximum occurred was 0.41. So that doesn't look like it. Let's check this one, see if it behaves any better. Yep, at negative 0.71, 0.41 is our maximum. At positive 0.64, negative 0.83 is our minimum. Looks like D is our choice. Okay. Find the domain of f. Well, is there anything that cannot be used for x? And in a polynomial, no, there isn't. So all real numbers is the domain of a polynomial function. And the range of the function, we can see that what's happening here, let's just big up the graph here. You see this is going to go up forever. It's going to go down forever. In fact, there is no limit to the values of y. Y is all real numbers in this case too. Sometimes polynomials will kind of have an absolute minimum or an absolute maximum you got to consider, but this one doesn't, So nice work we're going. So use the graph to determine where it's increasing, where it's decreasing. Okay, so again on the graph, let's get it medium sized. Looks like this thing is increasing from x equals negative infinity to x equals 0.71 negative. Okay, so that's one place. And then from positive 0.64 to infinity. That's where it's increasing, and it's decreasing from negative 0.71 equals x to 0.64 equals x. So remember these intervals, we're just looking at the values of x. Where does it go? So it's C. Okay, so I hope this helps.